Hey everybody, this is Larry. This is me doing week one of the Leetcode Daily Challenge or Weekly Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It's a premium problem. Let's play around with it. 1099, two sum less than k. Given the weight nums of integer and integer k, return the maximum sum such that there exists I less than j. Okay, so two numbers that add to each other where it is less than k strictly. Okay, so I mean, obviously you can do this in n square, and you could do it. It would just be very sad. It'll be very easy for sure. And during a contest, that's what I would be doing. But of course, even if you're not doing a contest, or if you're not doing a contest, and you're at least if you're interviewing or anything really, you want to do a little bit better. And what can you do? Well, one quick thing that you can do is, there are two things you can do. One is sort and then just scan, right? If you do a sort, then you can kind of do a binary search on the number that, if you have num sub I and num sub j, and you have stored up all the num sub j, so when you get to or when you store up all the num sub i's, so when you get to j's, you can do a binary search on the biggest number that's smaller than sum minus num sub j, right? So that's what you can do. Another thing that you can do without the sorting is, of course, also using a binary search tree. You can do that as well. That's also, both of those will be n log n. Another thing that you can do, of course, is noticing that this is less than 1,000, and if it's less than 1,000 and k is less than 2,000, then you can do effectively not a binary search but a linear scan, right? So you can scan down from and for each of those number, because you only need to scan at most say well, it's not possible, but yeah, you can scan at most 1,000 elements. It's going to be 100 times 1,000, but of course that is actually slower than n square in this particular case, so I would not recommend that. And also, I think I said you could search, and then you can. I said that you could sort and then do a binary search on each query, but of course you can also just do a two pointers thing, because as num sub I gets bigger, num sub j will get smaller, and so forth. All these things are things you can do. So definitely play around with all those techniques and all those ideas. There are a bunch of them, as you know. Yeah. I don't know which one I'm gonna do. Which one do I want to do? Okay, let's just do the binary search tree one, because I think it's a little bit different from previous before. So what am I? I don't know. What's sorted this? What is that from again? Oh man, I am blanking out there. It's not collection, right? It's sorted collections or something? Sorted containers, huh? Man, I'm just blanking out today. Sorted list, right? And then now basically what you want to do is, for x in nums, you search, basically you know that some x plus y is less than k, right? And you have x right now, so you're searching for y, so you minus x on both sides, so then you're searching for k minus x. You're trying to find the biggest number that is less than k minus x, so then you have now a sorted list, right, which contains all these x, all these y's. This becomes y in the future, right? So then now the search would be go to the bisect left of k minus x, and this will be the index. And of course you want this is the number that is k minus x equal to or bigger. So you want the one index that's smaller. So if index 1 is greater than or equal to 0, then SL of index minus 1 is going to be your number, but you actually want to know the maximum sum, right? So best is equal to max of best, this number plus x, and then that's it. Give it a quick submit. Roughly speaking, I mean, if you want to be pedantic and you know sorted list, I'm not going to go over it. But let's pretend that bisect left is log n, then this is going to be n log n for obvious reasons. That's all. And O of n space, of course, roughly speaking. That's all I have for this one. Let me know what you think. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.